So when we see this as a real equation, usually it's going to be a metal plus a non-metal, but not always. So let's look at an example. Let's say I have zinc. Zinc is a metal, so you should know at room temperature it would be at solid form, plus sulfur. So when I look at this, like, you should get in the habit of looking in this and go, oh, that's going to be a synthesis reaction. There's no way anything can replace anything else. Can't exchange anything. We can only combine. So then you have to think to yourself, okay, what am I going to get on the other side? So the first thing you want to do is look at the type of element present. Then you're going to decide the compound type. You're going to create the compound. And then the last thing you'll do is balance the equation. So no matter which type of reaction it is, you have to do the same things. So let's look at what you have here. Metal or non-metal? Zinc. Metal. Sulfur. Metal, non-metal. Metal, non-metal. Non-metal. Okay, so if I have a metal plus a non-metal, what kind of a compound am I making? Ionic. So over here I'm going to have an ionic compound, which tells me now I have to go to my periodic table and I have to find the charge of these things. So go to your periodic table, find the charge for zinc. What is it, Kins? Can you not find zinc? Okay. Help her out, Levi. 2 plus. How'd you know it was 2 plus? The triangle. Do you not have the magic triangle on your periodic table? Oh, okay. Okay, how about sulfur, Tucker? What's it become? It's 2 minus. So then I say to myself, how many of each do I need to balance out? What is the neutral compound? Danny?
What?
What's the neutral compound when those two things combine?
Oh, ZNS.
ZNS.
Wait, so why do you say that zinc's a solid but don't specify the zinc sulfur?
Why do I say zinc's a solid what?
Yeah, you have like zinc it has solid, but sulfur doesn't have a
Sulfur is one that normally we don't know the state. It could be a solid, it could be a gas. So but like I just expect you at this point to know if it's a metal at room temperature, it's a solid. Like if it's water, you put L after it for liquid. Okay, so there's one example. Let's see. Try this one. Like here's an example. We know chlorine is a gas. So figure out the other side of the equation. Oh, I didn't check. Yeah, the first one's balanced. That worked out nicely. We didn't do the last part. We created a compound and we didn't check the balance. Casey, what kind of compound are we gonna make? Gonna make ionic. What's the final formula work out to be? I know it's gonna be ionic. What's the charge on magnesium? Kenzie, try again. What's the charge on 2 plus? What's the charge on chlorine, Georgia? 1 minus. So what's my formula over here, Georgia? MgCl2. Now I can look at that because this is a pretty simple equation and see that it's already balanced, so I don't have to do anything. Try this one. What does hydrogen plus oxygen form? Water. H2O, which should be followed by what? An L for liquid. Now, is that balanced? No, so now you have to balance it. So I have 2 here, I have 2 over here, I have 2 oxygen. Over here I only have 1 oxygen. So I have to put a 2 out here to get it to a 2, which makes that a 2, but my H becomes a 4. So I have to come over here and put a 2 in front to make that a 4.
Why don't we just make it H2O2?
Why don't we just make it H2O2?
H2 plus O2, so that's not just
Because under normal circumstances, when when hydrogen and oxygen come together, you form water. If it were making hydrogen peroxide, there would be some other things that needed to happen. So this is the simplest kind of formula, the easiest ones to work with. Type 2 we'll look at. And it is called a single replacement reaction. Okay, if I have a single replacement reaction, I have a chemical reaction that starts with a compound and a free element and ends with a new compound and a new free element. So my algebraic expression looks like this. AB plus C yields AC plus B. Or we could say C or BC plus A. It would work either way. It depends on what you're dealing with. So here's an example equation. Let's say I'll use zinc again. I start with solid zinc. I'm going to put it in some hydrochloric acid. And on the other side of the equation, I will get We have to look at these things, again, you have to stop and look. Zinc is a metal, it forms a 2+ ion. Hydrogen can act as a metal or a nonmetal, it can form a cation or an anion, but because it's first in the equation, I know it's going to act as H+. I also know if I go to the periodic table, Cl is a minus. So that's the first thing you have to do. And then you have to look at this compound over here and go, okay, which part is zinc going to replace? The hydrogen or the chlorine?
Right now, the hydrogen.
The hydrogen, because the positive replaces the positive. So now I know my zinc is going to hook up with my chlorine. I just have to make a neutral compound. So zinc is 2+, chlorine is 1-, so I need ZnCl2, plus, how do I show my hydrogen? Plus what? Plus H. What do I need before the gas? H2 gas. It's one of the diatomic molecules, so you have to watch for those. Then I have to go back in and balance. My H's are not balanced, and my chlorines are not balanced. I have 2 of each on this side and only 1 of each on this side, so I'll put a 2 out here. And then my zincs are already balanced, so now I'm good. Okay, you try this one. So, first, find charges. Make the products. Balance the equation. Try it. See if you can work through it. Oh, wait. I wrote the wrong letter here. This should be an N. That'll mess you up. Sorry about that. Should be RB3N. When you're done, stand up. Is that where you work?
Yeah.
Really?
Miss Beal, guess what?
What?
My mom got some antibiotics coming in for me, and maybe I'll stop coughing.
Good.
And if they don't work, then I don't know what's going on.
Okay, so listen, check with your lab partners or partner. See if you agree, and then we'll talk about it.
Hey, you got two
You're
RB3
partnerless.
and three I2 solid yields RB6 I6 plus NP. I'm Jordan Corbin.
Okay, so I keep hearing RB6. I don't know what that is. Come back. Come back. Come back. I heard it out of a couple people. So let's look at this. What is the charge on rubidium? 1 plus. What's the charge on nitrogen?
I would have thought it was 3 plus because there's 3.
What is the charge on nitrogen? 3 minus. Thank you, Kinsey. Okay, and this has no charge as it stands because it's a diatomic molecule. If iodine is by itself, what's its charge? 1 minus. Okay, so what is my RB going to hook up with? Yes, so my RB is going to come over here. So, RB is a 1 plus, I is a 1 minus, so I only need one of each. Plus, what do I have left? Nitrogen. How do I have to write nitrogen? Has to have a 2 because it's a diatomic molecule. Now, is that balanced? I think it's not balanced. Balance it.
How do you do that?
Well, let's see. You work through it. RB, write them all down. N, I. This is what I'll be looking for on the quiz when we have balancing.
What does R and P mean?
What?
I don't know.
RB. It's an element, rubidium. It's the first part of the formula.
I meant like the things at the top, the R and the P.
Oh, reactants, products. I thought you were saying RB. Okay, so I have 3 here, I have 1, and I have 2. Over here I have 1, 2, 1. I'll let you try to balance it. Start with your rubidium. If I have 3 here and I only have 1 here, the first thing I'm going to try is putting a 3 here. That makes that a 3. It also makes my I a 3, which is not anything I want it to be, right? So let's keep moving. Let's look at our nitrogen, 1 to 2. So I want to make this a 2. To do that, I have to put a 2 out in front here, which now makes my rubidium a 6, my nitrogen a 2. So this is balanced. My I's and my RB's are still not balanced, so I'm going to look up here and I'm going to go 6, 3. Okay, they have a common multiple. Let's make this a 6 out here, and that gets my RB to 6, and now my I is a 6, right? So this is balanced. What can I do here to make this a 6? 2 times what is 6? 3. Thank you, Tucker. So that becomes a 6. So now everything is balanced.
Wait, so why originally, like, for when we first started to find the charges, why did we not consider RB3 3 plus because there's 3 of them?
Because you want to think about it in its elemental form, because you're not going to necessarily put 3 over here, because 3 RBs won't cancel out 1 iodine. Like, there's no reason to have RB3 I3. You want everything in its simplest form. Okay, let me have you try one more by yourself, and then I'll show you the third kind of reaction. Let's see. Periodic table. Yeah, that's a 3. Ca3 P2 plus K yields what? See if you can figure that one out. Get together with your lab partners and work through it all the way through. See if you can come up with the right answer. When you think you've got it, come back. Look, you're moving like an old man today. Be sure you check and make sure it's balanced. Okay, come back. Okay, so let's talk about this. What's the charge on calcium? What's the charge on phosphide? 3 minus. What's the charge on potassium? 1 plus. So that tells me that my calcium is going to come out of compound because it's going to be replaced by another positive. So I'll start by writing my calcium. And you didn't necessarily have, it doesn't matter which one you write first. I'm just doing that because I came to it first. Then I have to put my potassium and my phosphorus together. How many potassiums do I need for every 1 phosphorus? 3. So it would be plus K3P. Then I would balance.
Why don't we keep it B2?
What? Why don't we do P2? Because then that would be 6 minus to 3 plus. We don't, okay, stop and really pay attention to this. We don't automatically carry these over. These are to balance charge and make a neutral compound. So they might be different on this side. That's why we balance the equation in the end. So never think that these automatically move over. So let's look at what we have. Ca we have 3, P we have 2, K we have 1. Ca 1, P 1, K 3. So, now balance. Did anybody get it balanced already? What you got, Levi? What'd you do to calcium? Did you put a 3 here? Okay, so now that one works. Then did you put a 2 out here? Okay, if I put a 2 there, that becomes a 2, but that becomes a 6. So now I'm balanced here. Then I have to come back over here and fill in with a 6. Raise your hand if you got that.
I got it when you said the thing about not carrying them over.
Okay.
I got it after you wrote it.
Haha, Danny. Okay, let's look at the third kind. Tomorrow we're just going to practice these things. Third kind is called a decomposition reaction. This is a chemical reaction. It starts with a compound. And breaks down into individual elements or diatomic molecules. So my algebraic expression is AB breaks down to A plus B. Probably the most common equation example you would see if you look this up online or in a book would be H2O liquid breaks down to hydrogen gas plus oxygen gas. This, I'm going to write this in up here, could also be an atom and a simpler compound that it breaks down into. And we'll look at some of those too.
What do you need in there? But that's not balanced.
Well, it's not, this isn't balanced? Well, let's balance it. Let's put a 2 here and a 2 here. Now is it balanced? Yeah. Try this one. Let me think here. What happens to aluminum oxide?
Do we really even have to make a table for balancing these, like, really short ones where there's really not any work?
If it's a very simple one, you probably don't need to, but some of them you really will need to, especially when we get to combustion reactions.
Do we get explode stuff in here? Do we make stuff combust? Like, we in a lab, are we gonna combust things?
Hmm. The very last thing we do is a lab over all this stuff. Okay, what do I get on the other side? Who knows? Casey, do you know? What'd you write? You didn't write anything? Okay, what does it say? I start with one thing and I get 2. How many things does my one thing have in it? Yeah, it only has 2 things in it, so this should have been pretty simple. Al, which is a metal, so it's going to be solid, plus, how's oxygen? Yes, O2. And then I have to balance it. Now, when I see this 2 and 3, that tells me I'm going to have to do something. I can't just stick a 2 out here. So I'm gonna put a 2 out here, and that tells me to put a 3 here because that's 6 and that's 6. And now that gives me 4 aluminum, so I would have to put a 4 here. Yeah, Bailey?
How did you get AL02 before you balanced it?
How did I get what?
Wouldn't it be AL02?
No, because you don't carry these over.
But why is O2? Oh, because that's on Earth.
Because O is and one of the things that's always diatomic on Earth is one of your 7. Okay, type 4 is called a double replacement reaction. This is a reaction that starts with 2 compounds the reaction occurs and ends with 2 or more new compounds. So it's like A, B plus CD gives me AD plus CB. So let's do one of these real quick and then we'll be done.
Is that a CO or is that
This, I'm going to write it above so it's not so MgCl2. Okay. Get that in your notes, stop there, and we'll go through it tomorrow because these take a while. And this is HCl. That doesn't look very clear either.